This video will show how to capture an image group with the Leica GS18i GNSS RTK rover. The Leica GS18i gives the ability to capture images of the site and allows points to be measured from these images with survey-grade accuracy. This is made possible using visual positioning technology that is based on the seamless integration of GNSS, IMU and a camera. The GS18i works with Leica Captivate Field software and Leica Infinity Office software. This video will first show using the GS18i as a traditional RTK rover and then show how to capture images so that points can be measured in them later. Subsequent videos will show how the points are measured in the images. Let's see how to set up and use the GS18i. First, insert a battery and attach the antenna to the GS18i sensor. With the pole and the CS controller assembled, screw the sensor onto the top of the pole. To use the GS18i as a traditional RTK rover, align the sensor interface with the controller by adjusting the controller bracket on the pole. The GS18i is a tilt compensating GNSS rover, which means points can be measured without the need to hold the pole vertical. To make tilt compensated measurements, the IMU needs to be initialized. This is done automatically when having an RTK or SmartLink fixed position and the GNSS rover is moved around. Measurements can be made by placing the pole tip on the point to be measured without needing to level the pole. When measuring using a traditional GNSS RTK rover, there can often be obstructions which mean the point to be measured cannot be reached. This might be an object such as a building which disrupts the satellite signals, or a difficult to reach area such as the middle of a road or the bottom of a ditch. The GS18i can overcome these obstructions by being able to capture images of these areas and allows measuring points from these images later. To capture images of the obstructed area, it is simply needed to walk alongside the area to be measured whilst holding the RTK rover. There is no need to stop to take photographs from fixed point positions like when using similar technologies. To use the GS18i to capture images, the sensor must first be orientated so that the camera points towards either the left or right side, facing the area you want to capture. In Leica Captivate, access the GS Imaging app and go to Capture Image Group. The live video from the sensor's camera will be shown. Ensure you have an RTK or SmartLink fixed position and the tilt compensation is initialized, and then press Start. Now walk normally in a path alongside the area to be captured, between 2 and 10 meters away from it. For the best results, walk along at your normal pace in a slightly curved path. The capturing time is displayed with up to 60 seconds of image capture allowed. When the area has been captured, press Stop. The GNSS, IMU and image data will now be merged and processed. The number of images captured is displayed, along with the average positional quality of the image group. By pressing Store, the image group will be saved to your working job, ready to be used right away to make measurements in images. A subsequent video will show how measurements can be made in the captured images.
Alright everybody, Peyton Hatch again. Today's video is exciting. I wanted to show you a project that I got to work on just yesterday actually. Turn my video camera here. We essentially got to go out with a project, with a customer. And you can see it here on the screen. It's an intersection, fairly busy intersection, essentially 4 lanes in this direction, multiple lanes coming in from the north side. And we went out with the GS18i. And we initially shot basic control here. And then using the GS18i, we did multiple walks. So we wanted to establish this building here, the front of the building, then we wanted to do the other side of the building. And we also wanted the intersection. We wanted to see if we could collect data in the middle of the intersection without actually walking out there, bringing out a scanner or a robotic total station. So if you guys haven't seen GS18i data before, let me turn off this georeferenced image so I can show you here. It's similar to the way a drone works. You know, you go up and you say, hey, I want to take an image, and there's a camera right on the GS18. You walk slowly, it goes and it takes snapshots, and because the camera's tied into the GPS unit, you get these nice geolocated images. And with the IMU, the images are actually orientated as well. So essentially, we just walked around the building with our individual snapshots. So yeah, if you've seen drone data, you've seen that processing from, up at 300 feet, aiming straight down. So we'll go back here to a 2D view, 2D plan view, turn on that image again. So you can see here, we did a walk right here, then I did a second walk, just 30-second walks, and then we went over to the individual crosswalks, and we just walked down this crosswalk, and then we walked across the street, and then we walked over here, the whole time aiming the camera at the center of the road. So we'll zoom down here and show you one of these images. So you can see here is essentially what we were looking at. There were cars going by, everything. This was a very busy intersection, and it didn't matter at all. The data turned out fantastic. So what did this create? Let's turn on our point clouds. So I'll turn off my image group so we can get rid of the walks, but we'll turn on just the point clouds. Infinity has full post-processing capabilities with photogrammetry data. Just up here in your imaging, you can click on your point groups, and you can tell it to create a dense point cloud. And this was all done with the full resolution. I wanted to make sure I had 3 pixels per match to a quality of 2/10, not super tight, but I could have easily tightened that up. I just wanted to see what I could get. And the processing time to collect this data was, it was 30 seconds a walk. So essentially a minute to walk around the building, and then roughly 2 minutes to walk the intersection. And processing time was 10 minutes for the building and 7 minutes for the road. So hardly any time at all. I'm going to turn off my camera here so you can get a better view of the whole screen. I'll zoom in here. So here's the front of the building. This is what it created in 10 minutes with 1 minute of actual walking around this building. We've got the sidewalk. We've got the front of the building. We got the top of the building. We have underneath the awning. We have sidewalk shots. Those are usable shots. And I was just completely blown away at how clean this data came out. I mean, the bushes came out fantastic. And so now let's go over here to the road. The whole reason we wanted out here. So that road was very busy, and we didn't want to walk out in the intersection. So let me just create a random point here so I can get something to focus around. Yeah, we'll create that point right there. Come on, Infinity, create. There we go. Helps if you click on the spot where you want to create a point. So now I can center to this point. I can lock that for rotation. There we go. So you see here, all the cars actually got removed out. There was one that was sitting still the entire time, so we got that car. And we had this SUV right here that was sitting still the entire time we walked, so we were able to process that. But we got the road really well. It picked up the crown, and from here I was able to generate a surface, a couple of different surfaces. I found the interpolated surface to be the best, and I set a 2-foot spacing for my triangle size. That seemed to work out really well for me. So I'll turn off my point cloud, and here is my generated surface. So a few little spikes, but those are easily taken care of, and I never had to step 1 foot into that intersection and put myself in danger, or the team in danger at all. So yeah, guys, I am just ecstatic at the quality, the capability of that GS18i. So if you have any questions, please do not hesitate to let me know. I just look forward to showing everyone what this stuff can do. So thank you very much.